Hello students and welcome to Math Weekly 18.
In this Math Weekly, our focus skill will be on matching equations and graphs. So let's begin with what is the relationship between an equation and a graph? Equations and graphs both show a relationship between a set of inputs and outputs, which are also known as x and y values. So the question lies in, how can I decide if an equation and graph represent the same relationship? Well, here's how you find out. 1. Find a few, meaning 3 perfect points, which are x, y values with whole numbers. Second, use substitution to determine if each ordered pair is a solution to the equation. 3. If yes, then the equation and graph match. So let's look at an example. Let's practice determining which one of these equations matches this given graph. So the first step that we're going to do is find 3 perfect points. So here I see one right here, and this is the point 0, 2. I see another one right here, which is the point 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. And I see one right here, which would be 3, 4, 5, 7. Okay, so there's my 3 points that I'm going to test. And you could pick other points. You could have picked this one or this one or this one. There are many points you could pick. You just need to pick 3 just to make sure it matches the whole way. So let's start with our first equation. Y equals 2x, or y equals 2 times x. We are going to substitute each one of these in, and if all 3 of them can be solutions to this equation, then this will be the equation that represents that line. If not all of them can, then it's not the correct equation. So let's begin with the first one. So x is 0, y is 2. So 2 equals 2 times 0. Is that true? Does 2 equal 2 times 0? No, 2 does not equal 2 times 0, which is 0. So that means that this equation cannot be our equation that matches the graph. Let's look at the second one. Y equals x plus 2. Let's work on this one for our first point, 0, 2. So if I put 0 in for x, will I get y equal to 2? Let's try it. So y is 2, x is 0, plus 2. 0 plus 2 is 2. 2 equals 2. So this ordered pair is a solution to this graph. It's past step 1. Now let's check it for the next one as well. X is 3, y is 5. So 5 is equal to 3 plus 2. Is that true? Yes, 5 equals 5. That's good. It works for this ordered pair as well. Let's try one more. X is 5, y is 7. Is 7 equal to 5 plus 2? And that's true. 7 equals 5 plus 2, which is 7. So this equation matches this graph because all of the ordered pairs are solutions to this equation. And we can prove that the last one doesn't work. Let's take our middle point, 3, 5, and see if it works. Is 5 equal to 2 times 3 plus 2? Is 5 equal to 2 times 3, which is 6, plus 2? No, 5 does not equal 8. So you can see that this equation does not work for this. Only this equation will match any ordered pair on this line. Let's practice another example. Is this graph y equals x plus 5, y equals 5x plus 2, or y equals 2x plus 5? So our first step is we're going to find 3 points and we're going to check them. Personally, I like to always start at x is 0 because that's easiest. So here's the point 0, 5, and then I just try to stay close to it in the positives. So here is 1, 7, and right here is 2, comma 9. These are the three that I'm going to use. You could use points down here, but then you're going to deal with negatives and you're more likely to make a mistake. So let's start with our first equation and test it. Let's start with y equals x plus 5. So does y equal x plus 5? So let's put x is 0, y is 5. Does 5 equal 0 plus 5? Is 5 equal to 5? Yes, so it passed the first check, the first order pair. Now let's make sure that it works for all the rest. So now let's use the order pair 1, 7. Does 7, which is y, equal x, which is 1, plus 5? Does 7 equal 1 plus 5, which is 6? No. So even though it worked for our first order pair, it doesn't work for the second. So this cannot be the equation that we're looking for. So let's look at our second one. Is y equal to 5 times x plus 2 more? Let's try it for our first order pair of 0, 2. X is 0, y is 5. Sorry, 0, 5. So y is 5. Is 5 equal to 5 times x, which is 0, plus 2 more? Is 5 equal to 0 plus 2? Is 5 equal to 2? No. So this cannot be our equation. Now, we do not automatically say that the last one is correct because we could have made a mistake. We need to check it still. Y equals 2 times x plus 5. Let's try our first order pair. Our first order pair is 0, 5. 0 is x, y is 5. So is 5 equal to 2 times 0 plus 5 more? Is 5 equal to 2 times 0, which is 0, plus 5? Yes, 5 is equal to 5, so you can see it works for the first order pair. Now let's try the second one, 1 comma 7. We got y, which is 7. Is that equal to 2 times x, which is 1, plus 5 more? Is 7 equal to 2 times 1, which is 2, plus 5? Is 7 equal to 2 plus 5? Yes. So it works for the second order pair as well. And then we check it for the last one, 2, 9. Is 9 equal to 2 times 2 plus 5? Is 9 equal to 4 plus 5? Yeah, 9 equals 9. So you can see it works for all three. So this is our equation that matches this line. Y is equal to 2x plus 5. Let's try one more example. Is this graph y equals x minus 2, y equals negative 2 times x, or y equals negative 2 times x minus 2? So let's find three perfect points. All right, so here we have 0, 0. We have 1, negative 2. And right here we have 2, negative 4. So let's look at our first equation, which is y equals x minus 2. Is y, which is 0, equal to 0 minus 2? Remember our point 0, 0. So is 0 equal to 0 minus 2? Is 0 equal to 0 minus 2, which is negative 2? No. So that cannot be our equation. Let's try the second one. Y equals negative 2 times x. Our first order pair was 0, 0. Is y, which is 0, equal to negative 2 times 0? Is 0 equal to negative 2 times 0? Yeah, that's 0. So it works for the first point. Let's try the second one. 1, negative 2. Is y, which is negative 2, equal to negative 2 times x, which is 1? Is negative 2 equal to negative 2 times 1, which is negative 2? Yeah, that works. And then last, we have the point 2, negative 4. Is y, which is negative 4, equal to negative 2 times x, which is 2? Is negative 4 equal to negative 4? Yeah, so it works for that one as well. So this is our equation for the line. This line is y equals negative 2 times x. And you could go to check this one, and you would see it doesn't work. You could check just the very first point. Y equals negative 2 times x minus 2. Try that for 0, 0. Is y, which is 0, equal to negative 2 times 0 minus 2? Is 0 equal to negative 2 times 0, which is 0, minus 2? Is 0 equal to negative 2? No. So you can see this equation doesn't work either. Only y equals negative 2 times x works for any point along this line, even all the points that I did not choose. So let's summarize what we've learned about matching graphs and equations. Graphs and equations can both represent the same relationship. Both graphs and equations show a relationship between a set of inputs and outputs, which are x and y values. To decide if an equation matches a graph, first pick at least 3 perfect points from the graph. Second, use substitution to determine if each perfect point is a solution to the equation, and if yes, then the graph and equation match.